Hi guys, okay, Charlotte decides to model the shape of a cupcake to calculate its volume. She models the section 3.5 to 4.6 as a straight line. Find the equation of the line passing through these points. Okay, that, guys, as far as I'm concerned, is an easy question. It's just the gradient or the equation of a line. And in fact, it's really easy because one of these points is the y-intercept. So all I need is the gradient. So the gradient of this line is y2, well, it's y2 minus y1 over x2 minus x1, which is 6 minus 3.5 over 4 minus 0, which is 2.5 over 4, which is actually 5 over 8, if you like. And the y-intercept is 3.5, which is 7 over 2. So y is equal to mx, so 5 over 8x, because this is the gradient, mx plus c, and c is 3.5 or 7 over 2. 3.5 is certainly fine. Okay, that's the equation of the line. Part B. Okay, Charlotte then models the section of the cupcake that passes through these 4 points with a quadratic curve. Find the equation of the least squares regression quadratic curve for these 4 points, right? That, believe it or not, is even easier once I have my calculator. So all I have to do is put in these points. So it's 4, 6, 4, 6, 6.54, 6.54, 7, 3, and 7.50. Okay, I'll call that x, and I'll call that y. And then I just go menu, statistics, stack calculations, and I want quadratic regression. The x list is obviously x, the y list is obviously y. The rest is fine. Press OK, and I get this. So it gives me A, B, and C. So this is important. It's minus 0.97463. Minus 0.97463x squared plus 97463, yes, 9.5592, 9.5592x, 9.5592x, minus 16.657, minus 16.657. That's it. If you want, guys, as always, 3 significant figures, 975x squared plus 9.56x minus 16.7. That's the 3 significant figures. Okay. Next thing, he says, by considering the gradient of this curve when x equals 4, explain why it might not be a good model. Okay, so what is the gradient of this when x equals 4? Well, there's a few ways to find that. One would be differentiation. One would be actually to sketch the curve. Let's actually find the derivative of this when x equals 4. Or guys, another thing to think of it would be where would the maximum of this curve be? Let me just draw it so I don't have to explain the calculus. So we have minus 0.975x squared, and the 3 significant figures is fine for this, plus 9.56x minus 16.7. And then when x equals 4, let's do trace 4. Okay, so essentially what he's trying to say is on her model here, the quadratic, like the gradient should be negative, because at 4, 6, it's going down like this, whereas at the very least it should be 0. On this quadratic, it's actually going up, so it's like it's like if this quadratic was a good was the model, what's actually happening is it's going up like this. Hang on, let me do that again. It's going up like this and down like this, which definitely isn't a good fit. So I think this is only worth 1 mark. So all you have to say is that the gradient at x equals 4, the gradient of the curve is positive. And a better model, let's say a better model would have a negative gradient. That's definitely enough, a negative gradient. But that's what they want you to see, that it's really, it should go down like that, not up and then down. Okay, that's it guys, that's parts A and B. I'll do the next parts in the next video.